Hi friends, welcome to our YouTube channel. In this video we are discussing about arrays. Array is a linear data structure. Firstly, what is meant by array? Array is defined as a collection of similar types of data items stored at contiguous memory locations. In array the data items are called elements. The elements in an array can be accessed by using its index number. Array is mainly used when we know the number of elements, so we can clearly understand with an example. So consider example marks of a student in 6 subjects. We don't need to create 6 variables at 6 subjects. So we can create only one array that can store the marks of student in 6 subjects at continuous memory locations. Representation of array. An array collection of 4 elements A, B, C, D stored at the index 0, 1, 2, 3. So here the array is the name of the array and A, B, C, D are the elements of array. So here 0, 1, 2, 3 are the indexes. The array starts with 0 index. So here the length of the array is 4, but the index starts with 0. Here the first index or lower bound is 0 and the last index or upper bound is 3. Properties of array. There are some properties for an array. First one is each element in an array is of same data type and the size of the element is 4 bytes. Third one is elements in the array are stored at contiguous memory locations from which the first element is stored at the smallest memory location. Next point is types of arrays. Here there are mainly two types of arrays, single dimensional array and multi-dimensional array. Firstly, we will discuss the one dimensional array or single dimensional array. Declaration of one dimensional array. Declaration of one dimensional array is data type, array name and size equal to elements. Here consider an example of int array of 10 equal to 35, 33, 42, 10, 11, 19, 27, 44, 26, 31. Here int is the data type and array is the name of the array, where 10 is the size of the array. It can hold maximum 10 values only. The elements in an array must be separated by using comma. The index starts with 0 and the array's length is 10. And this is the representation of one-dimensional array in memory. Next, coming to the second point, two-dimensional arrays. Two-dimensional array is defined as the collection of data items of similar types given a single variable name by using two subscripts. Subscript nothing but index. Whereas the one-dimensional array definition is the collection of data items of similar types given a single variable name using only one subscript or only one index is called one-dimensional array. In two-dimensional array, the elements are represented as collection of rows and columns. And two-dimensional arrays are created to implement the relational databases that look alike data structures. And it is mainly used for to store the bulk of data. Declaration of two-dimensional array. The syntax of declaring two-dimensional array is data type, array name, and rows columns. Here int represents the type of the data, and array is the name of the array. Maximum rows means how many rows it can hold, and maximum columns means how many columns it can hold. We can initialize the elements into two-dimensional array by using the syntax int array 2 of 2 0 comma 1 comma 2 comma 3. So it can be written as int array 2 comma 2 equal to 0 comma 1 2 comma 3. It can be represented as a linear data structure or by using matrix. So in two-dimensional array, the number of elements that can be represented in a two-dimensional array will be always be equal to number of rows and number of columns. I mean, in two-dimensional array, the rows and columns number must be equal. Memory representation of multi-dimensional array. In two-dimensional array, the memory representation will be the in rows and columns. Here x 0 by 0. The first 0 indicates the row and second 0 indicates the column 0. Here x of 0 of 1, where 0 indicates the row 0 and 1 indicates the column 1. Like that here x 0 of 2, where 0 indicates the row 0 and 2 indicates the second column. Next coming to the second row. So x of 1 comma 0 or x of 1 of 0, where 1 represents the row 1 and 0 represents the 0 column. Like that x2 of 2, 2 represents the second row and this 2 represents the second column. So like that the two-dimensional array can be represented. So here this is the representation of two-dimensional array in memory. A of n comma n. I mean array of row of column. Some basic operations that can be performed in an arrays. Those are traversal operation, insertion operation, deletion operation, search operation, and update operation. Firstly, traversal operation. The traversal operation is used to print the elements of the array. And second one is insertion operation. The insertion operation is used to add an element at a particular index in an array. Deletion operation. The word delete means remove. So the deletion operation is used to delete an element from a particular index in an array. And search operation. The search operation is used to search an element using the given index or by the value in an array. And last one is update operation. The update operation is used to update an element at a particular index of an array. When we have to store the two-dimensional array into memory, we have to map the two-dimensional array into one-dimensional array. This is called mapping of two-dimensional array into one-dimensional array. So look at the figure. Here this is the two-dimensional array. It has the row indexes and column indexes. There are mainly two types of mappings. One is row measure ordering and second one is column measure ordering. First we will discuss about row measure ordering. In row measure ordering, all the rows of two-dimensional array are stored into the memory continuously. And the algorithm is the first row of the array is stored into the memory completely. After it completion, then it will go for the second row. The second row of the array is stored into the memory completely. And next the third row and next fourth row, and it will goes on like that and so on till the last row. So this is the representation. Here look at the arrows. Row measure order A11, A12, A13. After this row, come to the second row. A21, A22, A23. After completion of second row, go for third row. A31, A32, A33. Like this, the two-dimensional array is stored in the memory. Next, second one is column measure ordering. In column measure ordering, all the columns of the two-dimensional array are stored into the memory continuously. The algorithm is firstly the first column of the array is stored into the memory completely. After the completion of first column, the second row of the array is stored into the memory completely. Not second row, not second column. The second column of the array is stored into the memory completely. After completion of second row, it will go for the column. Third column. After completion of third column, it go for the fourth column and so on till the last column of the array. So come to the figure column measure ordering. In this figure, firstly A11, second A21, A31. After completion of first column, it enters into second column A12, A22, A32. After completion of second column, it goes to third column A13, A23, A33. So like that, the elements in the two-dimensional array will be stored at memory. So this is the thing we have to notice. So this is the general idea or basic idea of about arrays. So thanks for watching.